In this recording, we're going to talk about section or chapter 8. More specifically, we're going to be talking about chapter 8.1 that talks about the graph of sine and cosine. So to demonstrate the graph of sine, I'm going to play a video. So we're already familiar with the unit circle. So when we're doing the graph of sine, it's basically unfolding the unit circle. Okay, so I'm going to play that one more time so we can kind of see. As you go around the unit circle, the graph is being plotted on the XY plane. And so this is what a period or a complete revolution of the graph of sine would look like. Okay, so with this in mind, let's kind of derive the graph of sine for ourselves. Okay, so I'm going to draw the XY plane. But along my x-axis, I'm going to put the important points on the unit circle. So for instance, I'm going to use, of course, 0, 0 origin. Then you'll have pi. You can put pi over 2, or you can put pi. I'll put pi over 2. Then pi, 3 pi over 2, and 2 pi. You can also do the same on the left-hand side, but of course, they're going to be negative. Okay, and so if we look at the unit circle, notice that the highest point is 1, so my point here will be 1, and the lowest point is -1, so my point here, my point here would be -1. So now let's go around the unit circle to see what happens if each of these individual locations. So here, when we're at 0, right? Notice that for the sine graph, so if we recall, the coordinates here are cosine theta and sine theta, right? So sine corresponds to my y value. So I'm going to be looking at my y values to get my sine function. So here we have sine when x is 0. Sine is going to be also 0. Okay, when we're at pi over 2, notice that sine is 1, so we go up here. Okay, when we're at pi, notice that sine is again 0. When we're at 3 pi over 2, sine is -1, so we come down here. And then when we come back here is also 2 pi, right? Sine is 0. And if you go in the opposite direction, so if you go, recall, this would be your negative values. Sine is going to be -1. Then here, we're going to have 0. Then here, we're going to have 1. And then 0 again. So if I were to connect my dots, That's my graph of sine, okay? Alrighty. So this is a more accurate graph of sine. And so, of course, the graph of sine is periodic. What do I mean? If we look at the one that was just drawn, notice that if from here to here is being repeated, right? We started again, and it's actually repeated on and on for an infinite amount of times. So we would say that from 0 to 2 pi is the period, because that's the shape that's being kind of copy and paste throughout. Because if we keep going, that's the shape that we'll get again and again and again. So we have a period of 2 pi. When we talk about the altitude, we're talking about the height of the graph from the midline. So this is what we call the midline, the line that splits it in half. So the height of the graph from the midline to either the top or the highest point or the bottom point. And so notice that the unit here is 1. Our domain can be any x value, which is all real numbers, but your range, the height, is between 1 and -1. In a similar way, the way we unfold sine, we can also unfold cosine. So for instance, we'll use the same values as 0, pi over 2 pi, 3 pi over 2, and 2 pi. Also here, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. All right, and then here you'll have 1, -1. Okay, perfect. So now let's do the same thing we just did, but instead of looking at the y values or the y coordinate, we're going to look at the x coordinate, because recall cosine, this is cosine theta sine theta. So I'm going to be looking at my x for cosine, because we're doing the cosine graph. So at 0, cosine is 1. At pi over 2, cosine is 0 here. At pi, cosine is -1. At 3 pi over 2, cosine is 0. Yes. And at 2 pi, cosine is 1. We can do the same thing if you go in the opposite direction. Here, cosine is 0. Then cosine is -1. Then 0 again. And then 1. So if I were to graph this, there we go. That's the graph of cosine. And also, if you notice, we're going to also describe the period. So if you notice that the shape is being copied and pasted as well, this shape in particular is being copied and pasted to basically. Now, one thing I want to highlight is to get the graph of cosine, all you need to do is kind of shift the graph of sine, but we'll look at that later. So here we see that the period is going to be 2 pi. From 0 to 2 pi, that's the shape that's being copied and pasted. Again, your amplitude is the same. It's going to be 1. Our domain is still all real numbers, and our range is -1 to 1. All right, so a few characteristics that we just described for sine and cosine. period is 2 pi, your domain is negative infinity to infinity, and your range is negative 1 to 1. The graph of y equals sine of x is symmetric about the origin. All right, so if it's symmetric about the origin, whatever is in the first quadrant is going to be in the third, and whatever is in the third quadrant is going to be in the first. Okay, while the graph of y equals cosine is symmetric about the y-axis. Being symmetric about the y-axis means whatever is on the left will be on the right, and whatever is on the right will be on the left. So now let's say we have a general form for the sine and cosine function. So we have y equals a sine of bx minus c plus d, or y equals a cosine bx minus c plus c. Now, this is not different from the previous shifting that we have done, but there are little things that we have to make note of when we're doing our shifting. So for instance, if you wanted to find the period of the sine or cosine graph, well, the period is going to be equal to 2 pi over whatever b is. Your amplitude, again, which is the height from the midline to the very top of the graph or the very bottom of the graph, that's just the absolute value of whatever a is. Your phase shift, so you'll hear phase shift, but that really describes your starting point, or when you do a horizontal shift, that's a phase shift. That's going to be equal to c divided by b. And then your midline is y equals d. When we talk about the amplitude, that is going to be the vertical height. Oh, I just said that. Now, let's say we have an example where we want to determine the midline, amplitude, period, and phase shift of this function seen here. Maybe I should copy and paste these, and hopefully it goes in like a little corner somewhere. Alrighty, there we go. Alrighty, I'm just gonna, okay, I'll just put it here. In the corner somewhere. All right, so if we have that p equals, I guess it doesn't want to go over there. P equals 2 pi over b. So if we're finding the period, 2 pi over b. So recall that it's y equals a sine of a bx minus c plus d. So now, what is a in this what is b? B is going to be the number beside the, or the coefficient for your x term. In this case, it's going to be 2. So the period of this graph is going to be 2 pi divided by 2, which is going to be pi. And what that means is, if we're saying now that the period of this new graph, because it's being multiplied by 2, that means that it needs to fit, the shape of the sine graph needs to fit between 0 and pi. The amplitude is going to be the absolute value of a, which is 3. Your phase shift, so that's going to be equal to your c divided by your b. But notice that there is no c. So that tells me that it's going to be 0 divided by b, which is 0. This graph did not move. from the origin. Lastly, your midline. Your midline is going to be y equals d. Here, d is 1. All right, so now putting all of this together, let's graph this function. All right, so of course you can use whatever x values. Okay. All right, so firstly, our period is pi. Let's talk about the midline. Maybe that helps us. So let's go here. All right, so your midline is y equals 1. So this is like your half point, or your halfway point. Your amplitude is the height from the midline to the top or the bottom of the graph. So this means it's 3 units. I'm going to go up 3 units. So this is where my graph will be stopping. If I go down, this is where my graph will be stopping. Alrighty. Now recall that the period is pi, so that means I need to have a first sequence of the sine graph within this function here. So if you look at the previous sine graph that we drew, this is really this portion here is really the graph itself. So if I were to do a quick sketch, I will have, so I'm supposed to be between here and he's going to be really scrunched or stretched. Well, based on my my graph goes up in the middle somewhere, and three from here is 1, 2, 3. So this is here. So it looks some things like, let me try to make it a little bit wider so we can see. So it should look something like this. That's what it should look like with y being 1, your center. All right. Okay, so here we want to determine a formula for the cosine graph. Recall the shape of the cosine graph is this, right? Okay, so what we need to do is first establish the general equation, which is y equals a cosine of bx minus c plus d. So let's kind of see what we can identify here. Looks like my midline is 0.5, that's halfway. So if my midline is 0.5 and the height of the graph is 1, that means my A, which is my amplitude, is 0.5. Okay, D is my midline. I can also put that in. because my midline is at 0.5, so I'll put that in as well. Okay. All right, so bx minus c, b divided by c. Well, if you, let's see, b divided by c. Really, one way to find it, b of x minus c equals 0. Well, yeah, b divided by c. So if it's a cosine graph, recall that a cosine graph would usually be something like this, right? So we really seem to have shifted. Okay, we shifted this over here. So I guess you could say we shifted it 1 unit. So b could be seen as 1. So our graph is going to be y equals 0.05 cosine x plus 0.5. Okay. All right, we're just going to skip this one since we already did one up here, which was more complicated. All right. The same one. All right, so now what about cosine? So cosine is very similar. So my amplitude is going to be the absolute value of -2, which is 2. Very good. My midline is y equals d. All right, what else do we need? We need our shift, which is c divided by b. C is pi divided by b, which is pi over 4. Keep, change, flip. That's going to give me 4. Let's make this pi over 4 instead. Okay. It's really pi over 4. Pi over 4. And so if you divide it by itself, you get 1 for my phase shift. And then our amplitude of our phase shift, or period, let's see what's that going to be. Period is going to be I don't know, I must be super tired right now. 2 pi over p. There we go. All right, so yes, our period is going to be 2 pi over 4. Keep, change, flip. Pi's cancel, so my period is 8. All right, and so with that being said, since I have a number, I can just put that on my axis. Okay, so now my midline is at y equals 3. So 1, 2, 3. This is where my midline would be. And then my amplitude is 2, so I'm going to have up 2, down 2. So that's the height of the graph. My period was 8, so that means I need to draw the cosine graph within these from 0 to 8. So usually it looks like this, but we shifted 1 unit, so that means we're going to go to the right 1 unit here. So this is where we're going to now start. So it should look something like, so it's going to be a little bit of stretch. Oh, and it's also negative too, so that means it flips down. Okay, almost missed that. So should look something like that. Okay. All right, that's how we'll get the graph of cosine. Oh, well, that ends, or I guess I could just do that example then. All right, it says the London Eye of a huge Ferris wheel with a diameter of 135 meters. So it completes 1 rotation every 30 minutes. Riders board from a platform to meters above the ground. Express the rider's height above ground as a function of time in minutes. All right, so the London's Eye. Let's kind of see what we're given in this equation. The Ferris wheel has a diameter of 135 meters, completes 1 rotation every 30 minutes. So if it completes 1 rotation every 30 minutes, that tells me my period is 30. Because when we talk about our period, it's really when the graph gets that complete rotation. So my period is equal to 30 minutes. My midline, let's see, do we have that? Well, let's see, the riders board the platform 2 meters above ground. Okay, so we really have to like kind of read through to see what is what. So, okay, if we have a diameter of 135, then the wheel has a radius of 67.5, right? So our radius is 67.5, okay? So basically it's saying that if the radius of the Ferris wheel is 67, that means when it rotates, it's going to go up 67.5, or it's going to go down 67.5. So if you think about it, so let's say you have this Ferris wheel. It looks like this. As it goes up, it's going to go up as high as the radius, which is at 67.5, or it's going to go down, which is also 67.5. So basically, this amplitude, this is our amplitude here. Alrighty. All right, so what else do we need? We have our amplitude. Let's see, what about the midline? All right, so it says riders board from a platform 2 meters above ground. Two meters above ground. So if they're boarding 2 meters above ground, the center of the wheel must be located at 67.5 plus 2. Okay, because if the deck, let's say the deck is here, and they're boarding from 2 meters above ground, then that means the circle is kind of elevated 2 meters up from the ground. So that means the center would be at 67.5 plus 2, which is going to be 69.5. This is going to be my midline. Oh, we got to find all of this to put it all together in our equation. All right, so since we are starting at the bottom, if you think about it, the sine graph starts at the midline, right? And then comes up back. Cosine starts like so. But if you were to flip cosine, it will start from the bottom. So this would be, let's say, negative, and we're going to use the cosine graph. This looks more fitting. So it's going to be negative. A, we said our amplitude was 67.5. Negative 67.5 cosine. All right, so now our period is 30. Recall that the period is equal to what? 2 pi over b. So I can solve for b. Cross multiply, we'll see that 30b equals 2 pi. So divide both sides by 30. B is going to be can divide 2, so it's going to be pi over 15. So this is going to be cosine pi over 15x, right? Plus 69, which is my midline, 69.5. This might be a little bit of a stretch, but basically we use the fact that it has a complete rotation in 30 minutes to give us our period. We use the fact that a period is equal to 2 pi over b to help us find b. Then, since the Ferris wheel is being boarded 2 meters below deck, that means the circle is kind of elevated 2 meters up. So that means my midline, or the middle of the circle, is going to be at 69.2 or 69.5 because we're going to add 2 to the midline. And so basically you put everything together and you should get this equation. Okay, so we'll stop here for today. Be sure to check out your homework.